Hi folks, so this is question 8. So first part asks us to use the trapezoidal rule. So this is actually in your log tables. So I've taken this from the log tables exactly. So it's on page 12. So you see here, so what we're going to do is we're going to do h is the distance in between two of them basically. So that in this question will be 10. You'll see it up there. So h will be 10. Then what you do is you do the first one basically. So it's the first kind of line down pretty much. Now in the one up here, the one that in this question, we're going to add the two of them. So the one going up, there's nothing going up, it's just starting at this point here, but going down then it's 10. So y1 here is 10. And then the next thing is the yn. So the yn, that's the last one. Okay, so that's the last one kind of up or down. So the last one in this case, then there's just a point here at the end, so there's no kind of line up there or down. So in this case, our yn will be 0. The last kind of line up or down is 0. So yn equals 0. And then the rest of it then is just all of the lines in the middle. So you do plus 2 times then. So you do plus 2 times y2 plus y3 plus y4 plus all the way up to the second last one. So we're going to do plus 2 times, and then the first one will be 40 because we add those two together, plus another 30, we add 20 and 10 and 20, plus 30 and 20, plus 30 and 10, plus 20 and 20, and then that's it all put into the formula then. So I'll go through then. I'll put it into the formula down here then. So it'll be 10 over 2, so you're just following the formula out of the log tables now, times by, so it'll be 10 plus 0 plus 2 times, and then it's 40 plus 30 plus 50 plus 40 plus 40. And then that's it really. So you can go to your calculator then, or you can work it out kind of separately. So you should get 205. Sorry, 2050. And they're all in meters up here. Okay, all of them are measured in meters. So surface area then will be meter squared or square meters. Okay. Right, the next part then. So if the lake was 8 meters deep, estimate the volume. So volumes, remember volume of a cube or cuboid is length times width times height. So really you've kind of done the length times width up here. So you've kind of estimated that if that's the length and that's the width here, that what you get is that. So you've kind of multiplied 2 of them already. Therefore you're just going to multiply it by how far it goes down then. So you're kind of multiplying them all together. So it's 2050 you just have to multiply it by 8. That's all you have to do for this question. And then it's 16400, and then meters cubed. So cubed is always volume. Right, so you're on to the next part. So I have to calculate the volume of a hemisphere then. So there's a formula in your log tables again for this. So there's a formula for volume of a full sphere. Okay, so you're going to use that. So volume of a sphere is 4 over 3 pi r cubed. But that is that's the volume of a full sphere, but this is a hemisphere, it's only half of it. So therefore, what we're going to do is we're going to take this formula, but then we're going to divide by 2 at the end. And if you do that, it'll get the volume of just the hemisphere, just half the sphere. So 4 over 3 multiplied by pi multiplied by r, which is 21. So radius is 21 cubed, and then we're going to divide it by 2. So you can put all that in the calculator together if you want. Your answer, they tell you as well to give your answer in terms of pi. That means you leave pi in your answer, so it's what you get is 6174 pi, and it's a centimeter cubed again because we're still in volume. Okay, so a buoy on a lake is in the shape of a hemisphere. So it's basically, from the first part, you've just put that kind of cone shape onto the hemisphere. So the volume of the cone is equal to the volume of the hemisphere. So find the height of it all together. Right. Well, one thing we can see anyway, is that so the radius there is 21. So from there out is 21. That means from the center down also has to be 21. So that has to be 21 there. So that will be some of the height anyway. So up to there is 21 centimeters. So you just need to work out the rest of it then, really. You just need to work out from here up. So I didn't draw that very well. But yeah, basically from it's just the height of the cone we need to work out then. So we can work out that. So the volume of a cone anyway, volume of a cone formula is a half pi r squared h. That's the volume of a cone. So it tells us that the volume of the hemisphere is the same as the volume of the cone. It says that in the first sentence. Second sentence. So the volume of the cone is equal to the volume of the hemisphere. So that is equal to, we can give our first answer then, so 6174 pi. So those two have to be the same thing. They have to be equal. You can see here that the pi's will cancel out. There's a pi being multiplied on both sides. So we're left with half. Now radius, we actually know it as well. Radius is 21, so radius of the cone will be the same as the radius of the hemisphere. So half times 21 squared times h is equal to 6174. And then we just need to bring everything over to the other side then. So you could do it all in one go actually. We could do 6174 over a half times 21 squared. You could put all that in the calculator together if you want. I'm just taking a shortcut really. So you should get h is equal to 42. So what you've worked out is that the height, but remember that's just the height of the cone. So that's just from the top of the cone to the bottom of the cone. So that's 63. So all you need to do is just need to add those two together. 63 plus 21. Sorry, I've added them together myself. Sorry, we've worked out that that's 42. Yeah, so that's 42. So we need to add those two together, 42 and 21. So 42 plus 21 is 63. That's where I was getting 63 from. So centimeters. So that's it. And then part C. So for part C then, it asks us to calculate the angle QBP. So QBP is going to be from Q to B to P. So it's this one here. It's the one that's kind of labeled there anyway. So it's this one. So this is a cosine rule question. So if you're not sure how to use the cosine rule, then have a look. So the cosine rule says a squared equals b squared plus c squared minus 2bc cos a. That's in your log tables. So you just need to look for it in your log tables. The A will be the one furthest away from the angle, always the angle that you're dealing with here in the question. So the A has to be the 60. Squared A is always. Then B and C are the one that are always that are beside the angle that you're kind of using or trying to find. So B is 43 squared and C is 26, and we have to square it. So you can switch them around. Either you could put 26 first and 43 second if you want. So minus 2 times 43 times 26 times cos of A. And then you just need to move things across the equal sign then. Well, you can work out what they are first, so you can square all of them. So we should get 3,600 there. 43 squared is 2525. Sorry, added together, yeah, both of those things added together. So 43 squared plus 26 squared is 2525. Minus, and then if you do 2 times 43 times 26, you get 2236 times cos of A. So you can move the 2525 across the equal sign and just subtract it from 3600, so we get 1075 is equal to minus 2236 cos of A. And then we're going to divide across by this, by the minus 2236. So we get 1075 over, well, it'll be minus 2236 is equal to cos of A. And what you do then is you do cos of inverse, so you bring the cos basically across the equal sign. So it's cos inverse of minus 1075 over 2236, and you can put all that in the calculator and it'll tell you what A is. So I'm getting 118.74. That's it then. That's all for part C, and then that's everything for that question.